to start with number 14 from your final exam study guide. So on number 14, the question says you've got a water tank that can be filled in 7 minutes and emptied in 9 minutes. If the drain is accidentally left open when the tank is being filled, how long does it take to fill the tank? So what's happening here is you've got two things working against each other instead of working together. Like some of our problems were working together. These are actually working against each other. So we're going to be subtracting in this problem. But to begin, I'd like to remind you that work is rate times time. The amount of work you've accomplished is the rate you work times how long you work. So that's the concept you need to work this problem. So if the one thing can do the job in 7 minutes, it can completely fill the tank in 7 minutes, then its rate is 1/7 of a job per hour. So that's its rate, 1/7 times, time is the big unknown, how long, so time is unknown. So 1/7 times T is the work completed by the first drain, the first pipe. The other pipe is 9 minutes to do its job, which its job is to drain, so it's actually doing its job by draining the tank in 9 minutes. So its rate is 1/9 of a job per minute. So there's the rate times unknown time T. So there's the work for that one. And then to do these work problems, you set them equal to one job completed. If they're working together, if these two were both filling, we'd say plus, but since they're working against each other, we say minus. So rate times time, the work of this drain or pipe, subtract the other one, 1/9 rate times time, that work subtracts to be one job. And then to complete this, we times by the LCD, which is 63 on each side. When you times by 63, the 63 distributes. 63 times 1/7 is 9, so 9T. 63 times 1/9 is 7, so 7T. And then 63 times 1 to keep the balance here, 63. That's 2T is 63. Divide both sides by 2. And then that's your final answer on your study guide number 14, 63 over 2 minutes. Okay, number 15. Number 15 contains a radical. Remember, on your radical equations, you must always check your solutions to make sure they work in the original equation. You want to start by isolating your radical, so I throw this constant across the line. Again, step number 1, isolate the radical. Then we want to square. Since it's a square root, a squaring will undo that square root, so we square each side. So square this side will undo the radical, bring out the x plus 7. Squaring this side needs to be FOILed, so x minus 5 times x minus 5, or use your squaring pattern. That FOILs to be x squared minus 10x plus 25. So we see it as a quadratic equation, which means I need to get it in standard form, so I bring everything to one side, get it isolated or in standard form. So it's 0 on one side, combine the like terms on this other side, and so we have a quadratic equation in standard form. That needs to be either factored or put in the quadratic formula to solve, but this does factor. You can check that out, refoil that, it does work. You can then set each factor equal to 0, giving me two potential solutions of 9 and 2. Now again, I said potential because we have to check these back in the original equation to make sure they work. So one at a time, plug in the original equation. So 9 plus 7, again, we plugged in 9 for each one of these x's. And then 9 plus 7 is 16 plus 5. That is true. Square root of 16 is 4. 4 plus 5 is 9. So that solution works. Then we check the other one. Now plug in 2 for the x's. 2 plus 7 plus 5, does that equal 2? I have a feeling that one doesn't work. 2 plus 7 is 9. The square root of 9 is 3 plus 5. That does not equal 2. That does not work. It just happens out that way sometimes through this process. We compromise the sign when we square each side, and it causes issues with the solutions. So you just have to check these. That one is an extraneous solution. Did not work. So 9 is the only solution. You should bubble that in. Notice on the answer key, choice B has the 2 and the 9, so you've got to be careful about that. Since it's multiple choice, you've got to pay attention to these little fine details. So that's a choice, but it's not right. The only solution is the 9, the one that checks out in the problem. See, answer C. Okay, number 16. This would be from section 1.6 in your book. Other types of equations, just some other things that come up besides basic quadratics and linears, other types of equations. This is actually what we would call quadratic in form. It's not a true quadratic because these are raised to the 2/3 power instead of just squared. But it's quadratic in form if we could just pretend that was an x, or a u is what the book uses. It subs that out as a u, you can use any letter you want, and then that squared would be this part over here. So this chunk right here, x plus 3 to the 1/3, if I were to square that, I would multiply the exponents. 1/3 times 2 would be 2/3. So if this is u, this would be u squared. So I sub out the middle term, usually it's in the middle, and I call that my variable, my simplified substituted variable. So the book uses the letter u for that, usually when it explains that, but it could be any variable. But the idea is you're making an easier piece here, subbing it out. So again, if this is what we're going to define as being u, this will be u squared. So now we can rewrite the problem as that is u squared plus 2, that's what we're calling u, minus 15 equals 0. And then we have a simpler quadratic equation that we can solve by factoring. U plus 5, u minus 3. Set each solution equal to 0. This gives me 2 u solutions, which may be choices on the multiple choice test, but we're not done. Those are the substituted solutions. We have to then unsubstitute what u really is in our key here, where we let u stand in for that. We change it back into its real value. U is really x plus 3 to the 1/3. And we do that for both of these mini equations. And then solve these. So to solve x plus 3 to the 1/3, we could take this to the 3rd power. Because you multiply exponents, exponent to exponent, that cancels that out and brings out the x plus 3. Do the same thing to each side. Negative 5 cubed is 125, negative 125. Then you can throw the 3 over to solve for x, negative 128. Do that on this other side as well. So we cube each side to undo the 1/3 power. Cubing does that. Brings down the x plus 3. 3 to the 3rd is 27. Subtract the 3. Then your final 2 answers should be negative 128 and 24. You don't have to check this one, although I encourage you to check all of your answers. You could plug it back into the original problem, use your calculator, check that both of those do work. But if the algebra is right, this is one that should be okay if your algebra is correct. Okay, another one of that type, moving on number 17. We're using that idea as well. Number 17 is not a quadratic, but it is quadratic in form. We could make it into a quadratic by the substitution method. So x to the 4th, bringing this squared one over so it'll be in descending order, kind of standard form for this. So we can look at it. And you can see it's kind of like the last one. If this were just an x, it would be easier. An x and an x squared, it'd be a true quadratic. So we can pretend or substitute this x squared, just make it a u, and then if you squared that term, you'd get this x to the 4th. So if I call this u, then u squared would be over here. So, just like the last one, I'm just going to pretend that that is my simpler value. I'm going to let u stand in for that x squared. So substitution method it's called. So if I call that u, again, that makes that by default, because if you square that, I would have x4. So if that be u, that is u squared. So u squared minus 134, that's what I'm calling u, plus 1125 equals 0. Now it's a quadratic, so I solve by either factoring or the formula. I'm not overly familiar with the factors of 1125, so I'll have to punch around on my calculator a little bit to get that to work out, which I don't actually have on me at the second. Oh, I did have it actually. All right, so that's another thing that I know off the top of my head. So I'll work with my calculator, dividing that and see, let's see, 25 times 45 is 1125. I'll just make a note that does not multiply. It's got to be minus, minus to get a plus on the end, but a minus in the middle. So I know the signs are alike, so these terms should add to be 134, so that's not working. So I'm going to try something else. Divided by, let's see, 40, 1125, 35. I could look at the answer key and get maybe an idea of what works. I got it. Okay, so just by kind of randomly picking numbers until I get something that works there, 125 times 9 is 1125, and when I FOIL the inner, and the outer, that does combine to be negative 134U, the right middle number that I need. So, glad I got that to work. So once I get it factored, then I set each factor equal to 0. And that gives me U is 125 and U is 9. Remember, that's not the final answer. And once again, kind of watch this about a multiple choice test. The choice, that's choice B. And if you got in a hurry and like, wow, one of these answers matches something on my paper, you might jump in there and pick choice B. Not finish though, because that's what U equals. We're trying to solve for the original equation X. What is X? And that would not work back in the original problem. It works in the substituted, here, the pretend problem, the substituted problem, but not the real problem. So we say U from, where is this? We let U be X squared. So U needs to be changed back into X squared, and then solve that for the X. So to solve this, we have to square root both sides. When we square root, we have to say plus and minus of what we take the square root of. That will reduce 125, is not perfect, but it contains a set of 5s. If you break that down, it's 5 times 25, so it's 3 5s. So you can take a set of 5s, will bring a 5 out of the radical, and a 5 will be left over. So it's plus and minus 5 radical 5s. That's still showing up. Then on this side, we'll square root each side and have plus and minus 3. So we have a total of 4 solutions. It is a 4th degree equation, so you know we are always looking for that many solutions to it. Sometimes they're repeated solutions, but we should account for 4 total solutions. All right, so positive and negative of that, and positive and negative of that. All right. One more like that. Number 18 is the substitution idea as well, just kind of a complicated looking equation that we try to break down with simpler substituted values. So when you look at number 18, we have x to the negative 1 and x to the negative 2. Well, we don't like those negatives, so on our exponents, we can just take those off by the substitution property and then fix those back at the end like we did on the last one. So I'm going to substitute or pretend that that is just U, my substituted value. I'm going to let U stand in for x to the negative 1. If that is U, then this is the square of it. If you squared that term, a negative 1 times 2 would be negative 2. So this is the square of that. So I have 3 in front of that. That's what we're calling U squared, minus 9U plus 6. Now it is a quadratic, so I solve it by either factoring or using the formula. But you know, I notice I've got a 3, 9, and a 6, so why not divide that thing by 3? Everything's divisible by 3. We're allowed to do that, and it'll make the problem easier. That's optional. You could proceed with the 3's in it, but why not reduce this to an easier equivalent, totally equivalent problem? Then factor it. Or I could have just said factor out the 3, if that's another thought you had. But this will factor into U minus 2, U minus 1. The last is positive 2, and the inner, outer